Welcome to day 4. Today we tie everything together. So far this week, you have learned to think about a system from outside, name its building blocks, and design for quality. Today you produce a complete design pack, diagrams, decisions, trade-offs that you could hand to a senior engineer and say, "Review this, then I will start coding." This is the day that proves you have crossed from beginner to junior engineer. Take it seriously. Ask questions. The patterns you learn today are the same ones senior architects use. Yesterday, the toughest day. You learned scaling, reliability patterns, the OWASP Big 3, and observability. You produced an SLO map, a reliability runbook, a security review, and an observability plan. Today, we tie it all together. We move from individual decisions to a complete design pack, a stakeholder-ready set of diagrams and decisions. 5 concrete skills. 1. Draw container and component diagrams, see 4 levels 2 and 3. 2. Draw a sequence diagram for a real user journey including at least one error path. 3. Write an architecture decision record and a DR capturing context, decision, consequences, and alternatives. 4. Apply a structured trade-off framework to choose between 2 designs. 5. Run a 30-minute design review using a checklist and produce written feedback. Quick recap of the C4 model. 4 Zoom levels. Level 1, context. The system as one box with actors and external systems around it. You drew this on day 1. Level 2, container. The deployable units inside your system, web app, a PI, database, queue. We draw this today. Level 3, component. The major modules inside one container. Also today. Level 4, code, class diagram, rarely drawn by hand. Skip it for now. By the end of today, you will have produced one diagram at each of levels 1, 2, and 3. Same product, 3 different Zoom levels. A container diagram shows the deployable, runnable units inside your system. What goes in a box? The web app, the mobile app, the API service, the database, the cache, the queue, the object store, background workers. 1 box per deployable unit, not per microservice. What labels each box? The name claims a PI, the technology a SP.NET core on Azure App Service, and a 1-sentence responsibility, stores and validates expense claims. What goes on each arrow? A verb-led label, the protocol, the direction. Examples: reads via SQL, publishes to service bus, calls via HTTPS. Read your container diagram aloud top to bottom. If it sounds like a clear sentence describing the system, you have done it well. A component diagram zooms inside one container, usually the API service, and shows the major modules. What goes in a box? Major code-level units within one container. The auth module, the claims module, the payments adapter, the audit log, the notification dispatcher. These are not classes, that is level 4. They are not microservices either. Those are containers. They are responsibilities. How to know your component diagram is right. 3 tests. Each box has a single sentence responsibility. Replacing one box with another team's version would not break the others. The whole diagram fits on one A4 page. Match the diagram to the audience. Pick the smallest level that answers their question. If you are talking to a customer or a product manager, use context. They want to know what the system does and what it talks to. If you are onboarding a new developer, use container. They want to know what runs where, what's the database, what's the queue. If you are explaining to an engineer who maintains a service, use component. They want to know what modules are inside. If you are reading the code, you do not need a diagram. Just read the code. The mistake junior developers make is drawing every level for every audience. Be selective. Most of the time, you only need context plus one of container or component. Where C4 shows boxes, a sequence diagram shows time. It traces one user action across components top to bottom, 6 elements you'll use. A lifeline, a vertical dotted line, one per participant, a synchronous arrow with a closed head. The caller is waiting for a response. An asynchronous arrow with an open head. The caller does not wait. A return arrow dashed. The response to a synchronous call. An activation bar, a tall, thin rectangle on the lifeline, showing when the participant is doing work. And alt or opt fragments, boxes around alternative branches like an error path. 6 elements. That covers most flows you'll ever draw. Show the difference visually. The reader needs to see at a glance which calls block and which fire and forget. Synchronous. Caller waits for response. Solid arrow with closed head. Used for HTTP calls, SQL queries, gRPC. Pair with a dashed return arrow showing the response. Asynchronous. Caller does not wait. Solid arrow with open head. Used for queue publish, event emit, webhook fire. There is no return arrow. The sender moves on immediately. If your sequence diagram looks the same for sync and async, redraw it. The visual difference is what makes the diagram useful. Real flows have error paths. Use alt for either or branches. Use opt for this might happen, might not. Look at the example. The user submits a claim. The API tries to insert into the database. There is an alt block if the insert succeeded, return 201 created. Else if the insert failed, return 500 internal error. End of the alt block. This shows 2 paths in one diagram. Without the alt block, you would need 2 separate diagrams to show both. With the alt block, the reader sees both at once. This is one of the most useful features of a sequence diagram. Get comfortable using it. Mermaid lets you write diagrams as text. They render in GitHub in VS Code on a live editor at mermaid.live. Why text? It is diffable in Git. A reviewer can see exactly what changed line by line. There is no tool dependency. The diagram lives in your repo. It re-renders automatically when the source changes. What Mermaid supports: sequence diagrams, flowcharts, state diagrams, C4 in newer versions, Gantt charts, class diagrams, almost everything you would hand draw. The workflow today: sketch in Mermaid Live Editor, paste into a markdown file in your design pack, export PNG for submission. A worked example: the user submits a claim. The system stores it, notifies the manager, and waits for approval. Read the Mermaid code. There are 6 participants: the claimant, the web app, the claims API, Azure SQL, Service Bus, and Teams. The claimant taps Submit on the web app. The web app calls POST/claims on the API. The API inserts the claim into the database with status submitted. Then the API publishes a claim.submitted event to Service Bus. That is a sync. The API immediately returns 201 created to the web app. Service Bus delivers the message to Teams, which sends an adaptive card to the manager. That is the happy path. 6 lines of Mermaid. Anyone on the team can read this and understand exactly what happens when a claim is submitted. Now the error path. Most flows have a happy path and at least one error path. Show both. Read the Mermaid. The claimant uploads a claim with receipts. The API inserts the claim into the database. There is an alt block if the blob upload succeeds. The receipts go to blob storage and the user gets 201. Otherwise, if the blob upload fails, the API updates the claim's status back to draft with reason upload failed and returns 502 bad gateway with a retry after header of 5 seconds. Notice, The database insert succeeded. The blob upload failed. The system handles this correctly, does not lose the claim, but signals to the user that something went wrong and tells them how to retry. This is what good error handling looks like. Visible in the diagram. Reviewable. When you write up a design, 4 diagrams cover almost everything. Each answers a different question. C4 context, what is this system and what does it talk to? Audience, anyone. C4 container, what runs where, what's the database, what's the queue? Audience, developers. C4 component, what modules live inside the API service? Audience, maintainers. Sequence, how does this user journey play out across services? Audience, developers, and QA. You do not always need all 4. Pick what your reader actually needs. Now to decisions. An ADR is a short markdown document that captures one decision, what was decided, why, and what becomes harder. Why bother writing them? 6 months from now, someone will ask, why did we choose Postgres over Cosmos? Without an ADR, no one remembers. The decision was discussed in a meeting, the meeting notes are gone, and the team is left to argue it again. How long? 1 page, 5 sections, should fit on a phone screen. Where to keep them? Inside the repo in a folder called ADRs, numbered 0001, 0002, 0003. They live alongside the code. Use this template for every ADR. It is short for a reason. Section 1, the title. ADR 000X:, then a short title. Section 2, status. Proposed, accepted, or superseded by another ADR. Section 3, context. What is true today, what we don't know. Section 4, decision. The choice in active voice. Section 5, consequences. What becomes easier, harder, different. Section 6, alternatives. The honest list of rejected options and why. 5 sections. 500 words at most. The discipline is brevity. The 2 heart sections. Get these right, the rest follows. Context. The forces at play. What is true today? What constraints exist? What is not yet known? Example. Team of 10 with limited container experience. 6-week deadline. Expected concurrency under 50 requests per second. Strong preference for Azure native managed services. Write the context as if explaining to a new hire. They have no context. Give them what they need. Decision. The choice in active voice. Example. We host on Azure App Service Premium v3 with 2 instances and deployment slots for staging and production. Notice the language. We host. Not we will probably use or we are considering. Decisive. Include numbers when relevant. Be honest. Every decision creates winners and losers. List both. Easier, faster first deploy, simpler observability, single CI pipeline, the team can ramp up quickly. Harder. Any change requires redeploying everything. Per feature scaling not possible. Locked into app service tier limits. Different. The team will not learn container patterns inside this project. Mitigation, cross-train via a separate proof of concept. The senior engineer's habit. List at least 1 consequence that genuinely worries you. If everything is easier, you are not being honest with yourself. And a DR without alternatives is not a real decision. List the options you considered and explain honestly why they lost. Option B, Azure Container Apps with split web and workers. Rejected because the team velocity hit for ISC plus container build tooling outweighs the expected scaling benefit at this scale. Option C, Azure Functions Only. Rejected because the long-tail receipt upload latency profile is poorly suited to function cold starts. The rule: if you cannot list at least 1 alternative, you didn't really decide. You just picked the first thing that came to mind. Force yourself to find at least one rejected option per ADR. The architect's mindset. Every choice has costs. The job is not to find the perfect option, but to pick the one that fits the constraints. What gets traded? Time to market versus longevity. Cost versus scaling headroom. Simplicity versus flexibility. Familiar tech versus new tech. The structured way to analyze a trade-off. List the quality attributes the business actually cares about. Score each option on a scale of 1 to 5 against each attribute. Discuss the scores. Decide. The point of the score is not the math. The point is forcing the team to defend each cell, to explain why they gave option A a 4 and option B a 2 on operability. That conversation is where the decision actually gets made. Look at the example table. We are comparing app service, a single deployable with container apps split into web and workers for the GreenChit project. On time to first deploy, app service scores 5, container app scores 2. App service is 1 click. Container apps needs infrastructure as code and container registries. On cost at low spend, app service scores 5, container app scores 2. App service runs on a B1 tier. Container apps needs multiple replicas. On operability for a 10-person team, app service scores 4, container app scores 3, fewer moving parts in app service. On independent deploy, container app scores 5, app service scores 1. Container apps redeploys per service. App service is one big monolith. On future scaling, container app scores 5, app service scores 2. App service bottlenecks on a single instance. Total. Both score 17. A tie. Now the team has to decide what matters most for this project. Pick 5 to 7 from this list, the ones the business actually cares about for this project. Time to first deploy. How fast can we ship the first version? Operability. How easy is it for the team to run this in production? Cost. Infrastructure cost per month, especially at low spend. Independent deploy. Can we ship one feature without redeploying the rest? Future scaling. Will this still work at 10 times the load? Team familiarity. Does the team already know this tech? Talent supply. Can we hire people who know it? Lock in. How hard would it be to change vendor later? You will not score all of these in every project. Pick the 5 that matter for the decision at hand. Trade-off scoring is an argument tool, not a calculator. The wrong way. B got 17, A got 17, tied. Let's pick A because it sounds easier. You followed the math. You ignored the meaning the right way. For GreenChit, time to deploy and cost are the dominant attributes. We have 6 weeks and a tight budget. Therefore, A wins on the 2 attributes that matter, even though scaling is weaker. Notice the difference. The right way is explicit about which 1 or 2 attributes drove the decision. That is what makes the decision defensible later, when someone questions it. Use these 5 questions in every design review you do. They cover 90% of what matters. 1. Does it solve the stated problem? Reread the requirements with the design open. Anything missing? 2. Are the failure modes considered? Pull a card from yesterday's runbook. Does the design cover it? 3. Are trade-offs explicit? Was at least one alternative considered and rejected, with reasons? 4. Could a new engineer pick this up? Does the README walk through the diagrams in order? 5. Where would I push back? Every reviewer should leave at least one disagreement. Agreement-only review is theater. Print this. Pin it. Use it on every design review you join. Design reviews go 2 ways. You give feedback, you receive feedback. Both are skills. Giving feedback, be specific. Quote the line, propose a rewrite. Lead with strengths 3 of them, then risks 3 of them, then concrete improvements at most 3. Disagreement is welcome, but disagree on the work, not the person. Receiving feedback. Listen first. Resist the urge to defend. Ask what specifically. Before you respond, document what you accept and what you push back on. Both are valid. Thank the reviewer. Honestly. They saved you debugging time later. The dynamic of a good review. Both sides leave with something better than they came in with. Today's challenge is GreenChit. The brief. GreenChit is an internal BISTEC tool for staff expense reimbursements. Staff submit claims with receipts. The line manager approves. Finance exports approved claims to the payroll system. The audit log captures every state change. Your job. Produce a complete design pack, a container plus component diagrams, a sequence diagram for submit and approve, 3 ADRs, and a trade-off table comparing 2 architecture options. Then review. At the end, you will swap design packs with another pair and run the design review checklist on theirs. Time. About 50 minutes in hour 3 to design. 25 minutes in hour 4 to review. Your final deliverable is a folder with this exact structure. A new engineer should be able to clone it and understand the design from the README alone. GreenChit design / readme.markdown. Diagrams folder containing container diagram.png, component diagram.png, and sequence.markdown. A DRS folder with at least 3 numbered ADR files. Trade-offs folder with the hosting options analysis. Everything in Markdown and PNG. Everything in Git. Everything readable on a phone. This is what professional design output looks like. Build the habit now. Same shape as before. 100 points total. Pass mark 75. Deliverable 1. The container plus component diagrams. 1 C4 level 2 and 1 level 3 both consistent in notation. Deliverable 2. The sequence diagram. Mermaid sequence for submit and approve. Happy path plus at least 1 error fragment. Deliverable 3. The ADR set. 3 ADRs covering decisions taken in the design. Each follows the 5-section template. Deliverable 4. Trade-off plus design review. A scored trade-off table. Then feedback given to and received from another pair. 3 tools. Draw.io for container and component diagrams. The C4 shapes are built in. Save the source file alongside the PNG export. Mermaid Live for sequence diagrams as text. Edit on the left, see render on the right. Copy the markdown into your design pack. VS Code with the ADR Tools extension. For writing ADRs in Markdown, the extension scaffolds new ADRs with the template. Just type a title. All free.
Yep.
You can now produce a complete design pack, diagrams, ADRs, trade-offs. You ran a real design review. Tomorrow is the most important day of the week. Tonight, 6 things to lock it in. 1. Read 3 public ADRs from open source projects, Backstage, Open Telemetry. Note 1 practice you would adopt. 2. Add a 5th ADR covering an observability or security decision. 3. Export your Mermaid diagrams as PNG and SVG. Check both render in your README. 4. Reread your trade-off table after a night's sleep. Change 1 cell. Document why. 5. Write a what this design will not do in version 1 paragraph for your README. 6. Add 2 questions about today to your learning log.md. Tomorrow, day 5. Specs as contracts. The bridge into a I-enabled spec-driven development. The most important day of the week. See you at 9.